everyone, welcome back to Sri Sampath Vinayaka Learn Easy channel. Now we will discuss how to prove the given number as an irrational number. Given number in the sense the numbers which are in the form of root A into root B, A plus or minus root B, okay, root A plus root B. These are the four different models. Okay, now how to prove these four different models as an irrational numbers we are going to discuss now. Firstly, I am going to write those four irrational numbers. For example, first one, this is root A. Second one, A plus or minus root B. Third one, A into root B. Fourth one, root A plus or minus root B. Okay, now these are the four different models. Okay, now to which we are going to prove as an irrational numbers. We know that sum of a rational and irrational is always irrational. The product of a rational and irrational is always irrational. The sum of two irrationals or the product of two irrationals may be rational or may not be rational. Clear ma? So, but here this A and B are prime numbers. In this case, sum of two irrationals is irrational and the difference of two irrationals is also irrational because this A and B are prime numbers. Okay. Now we will discuss one by one models. Okay, Nama? Now Seema, we will discuss the model 1. That is the numbers which are in the form of root A where A is a prime. For example, root 5, root 3, root 7, root 11, root 2, so on. These are the examples for this model. Okay. How to prove such type of the irrational numbers as irrationals? We know all these are irrationals, but we have to prove that as irrational. In this case, we are going to use proof by contradiction, that is indirect proof. In this indirect proof, firstly we have to assume that root A is a rational number. That means we are assuming wrongly. Okay, and in the final case we will get a wrong value. That is a contradicted statement we will achieve. That indicates the assumption is wrong. So that is why this method of proving is known as indirect proof or proof by contradiction. Okay, Nama? We will prove all these models in indirect proof. Now we will prove such type of given irrationals as irrational by the following steps. Step 1. In this step 1, we have to assume root A as rational. As root A is rational, then we have to express that as root A is equal to P by Q, where P comma Q are co-primes. Co-primes and relatively primes are the same. Co-primes or relatively primes means that P and Q are going to have 1 as the greatest common factor. Okay, that is the key point to solve this particular models. Okay, now step 2. In this step 2, squaring on both sides. We have to square both sides. Okay, then root A whole square is equal to P by Q whole square. That indicates A is equal to P square by Q square. By this I will write P square by A is equal to Q square. Okay, here observe this. P square is a square number. Now A is a prime. Okay, if a square number is divisible by a prime, then that number is also divisible by the same prime. That is theorem 1.6. We already learned it. So that's why this P square is divisible by the prime A. So this P is also divisible by the prime A. That is step 3. Just we have to write the statement. Here p square is divisible by prime a. So p is also divisible by a. That is, p is expressed as sum a into x. Sum a into x. We have to assume this one as 1 and this one as 2. Now step 4. In this step 4, substitute 2 in 1 that indicates ax whole square by a is equal to q square that implies a square x square by a is equal to q square. That implies, tell me just, x square is equal to, here 1a and 1a will cancel out, 1a left, that a is going to be transferred to the other side, that is q square by a. See, again the same old step 3 is repeated here. Okay, here q square is divisible by the prime a, so q is also divisible by the prime a. So step 3 we will repeat here this step 3 here repeated, that is q is equal to sum again a into y. This is our equation 3. From 2 and 3 just observe this p and q are having a as common factor. This p and q are having a as common factor. That is why our assumption is going to be wrong, because for p and q is having only 1 as the greatest factor, because p comma q are co-primes here. But here we obtain p comma q as having a greatest factor as a, that is a is a prime number. We know that prime numbers are greater than 1. That indicates p comma q are having a greatest common factor other than 1. That indicates our assumption wrong. Okay, now our assumption is root a is rational. Our assumption root a is rational. That is wrong. So root a is irrational. Finally we are going to conclude that. Okay, this is model 1 Okay, finally what we are going to conclude from 2 and 3. Okay, p comma q are having a as common factor, which contradicts our assumption. Which contradicts our assumption. Okay, now simply here I will write sigma, lack of space, that is root a is an irrational number. Okay, this is our final conclusion. That is our step 5. Okay, now this is our step 5. Okay, in this way we will prove the model 1. That means if he asks us to prove root 7 as an irrational number, simply we have to write root 7 as a rational number. See, we have to assume root 7 as a rational number. So that is step 1. That is root 7 is equal to some p by q, where p comma q are co-primes. Squaring on both sides, that is root 7 whole square is equal to p by q whole square we have to write. Okay, nama? Then 7 is equal to p square by q square. Okay, again I will transfer this 7 to the place of q square and I will bring back this q square to here. Then q square is equal to p square by 7. That means the prime number 7 divides p square. So the 7 divides p also. So p is equal to some 7 into x. Similarly q is equal to some 7 into y. From this 2 and 3 we will write p comma q are having 7 as the greatest common factor. That indicates our assumption is wrong. Our assumption is wrong means root 7 is irrational. Okay, na? Sima, we have to prove root 7 as an irrational number. For that our step 1 is let root 7 is a rational number. Okay, Nama? So step 1, let root 7 is a rational number, ma. That is, root 7 is expressed as some p by q where p comma q are co-primes. Okay, Nama? Now step 2, ma. Coming to this step 2, we have to squaring on both sides, ma. That is, root 7 whole square is equal to p by q whole square, ma. That implies 7 is equal to p square by q square. Just transfer this q square to this left side and transfer back this 7 to the denominator, ma. Then q square is equal to p square by 7. Here see, this p square is a square number and 7 is a prime. That means the square number is divisible by a prime 7. So that number is also divisible by the prime 7, ma. That is theorem 1.6. Okay, now that is clearly p square is divisible by prime 7. Okay, now so p is also divisible by 7. Okay, Nama? So we have to express that p as some 7 into x, ma. That is our equation 2. Why? Because this p is divisible by 7, ma. If a number is divisible by some prime p, that number is expressed as that prime into some other number, ma. That is why p is expressed as 7 into x. Okay. Now I will substitute this p value in equation 1, ma. Okay. Substitute 2 in 1. By that we will get q square is equal to 7x whole square by 7, ma. That gives us 7x square. Why? Because 1 7 and another 7 is going to be cancelled here. Okay, now I will write from this x square is equal to q square by 7. This 7 is going to be transferred to the left side. Okay, now just observe this one, ma. Again this step 2 is going to be repeated here. So x square is equal to q square by 7 means, okay, now sorry, ma, this is step 3. This is step 4, ma. Okay, and this step 3 again going to be repeated here. Why? Because see, that q square is divisible by the prime 7. So that q is also divisible by the same prime 7, ma. So I will write that is q square is divisible by prime 7. So q is also divisible by 7, ma. Okay, na? That is q is equal to some 7 into y. Okay, na, ma? So we have to assume this as 3. Okay, na? 1 c, ma. From 2 and 3, p comma q are having 7 as common factor. Okay, but p comma q are co-primes, ma. As p comma q are co-primes, p comma q must have 1 as the greatest common factor. But here we arrived that 7 as the greatest common factor. That contradicts our assumption. That means that opposes our assumption. So our assumption is wrong. What is our assumption, ma? Root 7 as a rational number. That's our assumption. So this assumption is wrong. That means root 7 is irrational. Okay, now root 7 as 7 as common factor. So it contradicts our assumption. That is step 5, ma. that is root 7 is irrational. Root 7 is irrational. Okay, I hope you understand. Now, if he asks you to prove root 13 as an irrational number, just replace that 7 with 13. Okay, I hope you understand.